Hello, everyone. Today we're going to be talking about slope and rate of change. So let's go over our essential question, content objective and language objective. Normally we would do this as a choral reading, but because you're watching a pre-recorded video, I'm going to go ahead and read it all. So it says, how can slope or rate of change be determined? So that's the main question we're going to be going over today. We will be able to determine the slope or rate of change of a graph or 2 points. And we will collaborate with our peers to find the slope of a graph. So for slope in real life, we have a hill. So we have hill A, and it's 30 yards long and 20 yards high. And we have another hill that's 20 yards long and 20 yards high. So consider the two hills shown on the left. Which hill do you think is going to be steeper? Do you think this one will be steeper or this one? Okay, now that you've had a minute to think, a couple seconds to think about that, I hope you chose hill B. You can tell either just by looking at it, or you could tell by viewing the distance. So you're going up the same amount of yardage. They're both going up 20 yards high, but this one is going up faster. It's going up 20 yards within 20 yards, and this one takes 30 yards to get up 20 yards. So you can tell that this one's increasing at a faster rate. And so y is why we just went over that. So the horizontal distance is shorter than the other hill. So that's why hill B is bigger, which is the exact same thing that I just did, just in a different way. So slope definitions. On graphs of linear relationships, slope describes the steepness of a line. The slope is the ratio of the vertical change compared to the horizontal change, or known as rise over run. So you put the amount that it's rising over the amount that it's running, so which means going left to right, this one's top to bottom. Slope is equal to the rate of change of a graph. So slope and rate of change are the exact same thing. It's just a different term to use. So they're interchangeable. If you're being asked what the slope of a graph is or what the rate of change of the graph is, just keep in mind that they're going to be the same thing. So we have 4 different types of slopes that we're going to discuss today. So the first type of slope looks like this. It'll be any type of graph that is rising from, when you go from left to right, you're always going to read these left to right, just like we read our domain. If it's rising as you go left to right, it's going to be considered positive. It's a positive slope because you're going up and you're going to the right. Now, let's read the next one. So we're going down. So as we're going from left to right, we're going down and we're going to the right. So this one's going to be negative over a positive, which is going to make it a negative steepness, or sorry, negative slope. Now we're going to look at the next one. We're going only to the right. We have no change going up or down. We're only going to the right. So that's going to be known as a zero slope. Just know that there's zero change in the level that you're going. So that's why it's a zero slope. Our next one is we're going up and we're going down, depending on the way that you're looking at it, but we're going up forever and we're going down forever, but we're never moving left to right. So as we write this, our rise is a plus or a negative, and our run is 0. Well, this is something that we discussed before. You can never divide by 0. Since you can't divide by 0, our slope is going to be undefined. So if you write it as a fraction, you put your rise and your run is 0. Just know it's always going to be undefined. So for these two, their special circumstances, we have another slide that will help us give you something to remember that by. So this is called HOY VUX. So we got two different terms. We have HOY and we have VUX that are going to be an acronym that you can remember to help you remember which slope is going to be what and what the equation looks like when you see it. So HOY VUX. HOY stands for horizontal, so a horizontal line, zero slope, and it's y equals a constant. So your equation would be y equals 6. While VUX is a vertical line, so it goes up and down vertical with an undefined slope, and x equals a constant. So x equals 6. And I was going to change that to a different number, but I forgot. So horizontal, zero slope, y equals. Vertical, undefined slope, x equals. If you can remember HOY VUX, and just kind of like remember, don't call me after midnight. It's just something that it's an acronym that'll help you remember what things stand for. Whenever you have a question about something with a zero slope or an undefined slope, you can easily write an equation for them because you know zero, you're going to have y equals, undefined, you're going to have x equals. And we'll go over this a couple more times whenever we do practice problems with horizontal or vertical lines. And this is just an easier way to remember. So we're going to go ahead and we're going to do a practice problem. So we're going to go ahead and pick the slope of the line. Now, when finding a slope of the line, the first thing you have to do is have 2 dots. Now, it's not always going to give you the 2 dots. So what I like to do is tell you to find a pretty dot. You want it to be the center of 4 squares. So this is the center of 4 squares because it touches this one, this one, this one, this one. So this was a pretty dot. This one would not be a pretty dot because I don't know what fraction that is. This one's not a pretty dot, not a pretty dot. We want it to be just like our origin is in the middle of 4 squares. So we have 2 pretty dots already placed for us. We have a pretty dot right here and a pretty dot right here. So we're going to calculate the rise over run. So we're going to go, so here's my pretty points. We found them. We're going to find the vertical change, which is the rise. So we're going up and we go up by 1, 2. And we go find our horizontal change, which is our run. And we go over by 1, 2, 3. So writing it as rise over run, we're going to have 2 over 3. Now, when it comes to slope and rate of change, we want to keep it in our fraction. Sometimes when you get fractions, you want to go ahead and automatically change it to a decimal, but this is going to help you when graphing. I know I go up 2 over 3, and if that's all it gave me and I wanted to find more dots on there, I would go up 2 over 3, and it just helps it so it's easier to graph. So that was our first problem. Let's go ahead and look at problem 2. Same steps. This time it does not give us pretty dots or pretty points. So we actually have to find our own pretty points. So let's go ahead and look at some of these. So right here, here's a pretty point. Here's a pretty point. And here's a pretty point. I don't want to do the arrows because I don't know if they're quite there. That arrow looks like it's touching, but I can't quite see it. So we're going to pick the ones that we can tell for a fact are pretty points. So I'm going to pick this dot because it looks pretty. I'm going to go ahead and pick this dot. Keep in mind, you can pick any 2 dots that works for you. The only thing is they're going to equal the same slope. It's just you might have to simplify a little more. So we're going to go ahead and find what our rise and our run is, paying very close attention to what our graph is counting by, because if you're just counting the squares, you're going to get the answer wrong because this one's actually going by 2s. So rise, we're going down, so it's negative, and we're going down 2 because our squares are going by 2. And we're going over, because we always go left to right, we're going over 4. So when I write this, I'm going to have -2 over 4. Well, those are both even numbers, so I know I can simplify. So this is equivalent. I want to make sure I'm not covering up anything. We'll put it over here. So this is equivalent to -1/2. So they can simplify. So if I had picked this point instead, right here, when I simplified it, it would still simplify to -1/2. It might look a little different, but the slopes would be the same. So let's do another practice problem. So let's do number 3. Same process. Find 2 pretty points. Find the vertical change and then the horizontal change. So I have a lot of pretty points here. I could pick this one, this one, this one. There's so many to choose from. So I'm just going to pick some. I'm going to pick this pretty dot. I'm going to pick this pretty point. And it's going up, and it went up from 5 to 15. So it went up 10. And it went over 0. So we're going to have 10 over 0. Well, that looks a little weird. Okay, that I remember now. I can't divide by 0. It's not possible. So my slope is going to be undefined. Another way I could have done that without doing any work, this is a vertical line, and vertical line in VUX is undefined. And remember, this is a pre-recorded video. If for any reason I am going too fast for you, feel free to pause, rewind, and stop anytime that you need. And you could always rewatch anything. Okay, so I'm gonna put this over here for now. So it says Clark loads boxes of paper on a pallet before shipping them. The graph shows the linear relationship between the number of boxes on the pallet and their total weight. Find the rate of change with respect to the number of boxes. So that's just saying what is the rate of change of X? Because look, over here it says number of boxes is X. They like to throw in some extra words sometimes to try to confuse you. I know that happened on the last test when people said with what is a function in respect to X. I know that threw a couple of y'all off. So just keep in mind, it's just a little bit of extra words. Look for the key words it's asking for. This is saying rate of change. So we find our 2 pretty dots that are already placed for us. And we're going to find our rise, looking very carefully at what we're going up by. We're going up by tens. So our rise, we're going up 10, 20, and we're going over 1, 2, 3, 4. So our rise is 20, our run is 4, so 20 over 4. And I can simplify this, they're both even. So 20 divided by 4 is 5. So my rate of change is 5. So what that means is that whenever I am loading boxes of pallets before shipping them, I'm loading about 5 boxes each time. Or 5 pounds per box, I think is what it is. 5 pounds per box. So that's how you would solve this rate of change. So the weight's going by the number of boxes. So each box is about 5 pounds. See how this looks like 5, 2 boxes is 10. That's what you would find out by that problem using the real world information. So we have another word problem. Lainey set up lemonade stand. The graph shows the amount of money in her cash register with respect to the number of customers Lainey has served. Find her rate of change. Okay, well, this one does not give us pretty points, so we have to find our own pretty points. Sometimes it's easier if I find one that's on one of the axes. So I see a perfect point right here. That one would be a fraction, fraction, fraction. And like I said, I want it to be in the middle of 4 squares. Here's one. I'm sure I can go further, but let's go ahead and plot our pretty points. I found this one and I found this one. Ooh, but there was another one. So you can pick other dots as well. So we picked this one, but it would be the same if I simplified it. So let's go ahead and pick our rise over run. We're going up 1, 2, 3, 4, 5, 6. And we're going over 1, 2, 3, 4, 5, 6, 7, 8. So we have rise of 6, run of 8. Once again, they're both even, so I am able to simplify to 3/4. So my slope or rate of change, they are the same, is 3/4. Okay, so that's pretty much rate of change. There is going to be a couple more types of problems that we may learn. So that's Friday. I want you to get some more practice with it. So what I'm going to have you do is you're going to go ahead and jump on iExcel to do some practice problems. The practice code that we're going to be doing today is E7D. Do at least 10 questions with your goal of a SMART score of 70. Once you feel confident, start working on your assignment 3.1 slope and rate of change. This is the last 50% of your weekly grade. The first 50% was from Unit 2, the review of properties of functions. Another reminder, the end of the 9 weeks is next Friday, November 6th. So make sure that you've done all your missing assignments or brought up any late grades that you might have or anything that might have been low. So make sure you're completing that. On Canvas, if you are needing extra help, since I'm not going to be here today, there is tutor.com, which is a 24-hour tutor service that you are able to use. Just go ahead and log on. It'll get you with a one-on-one tutor that will help you with algebra or any other course that you might need. So if you're needing help in class, just go ahead and log into tutor.com and it will help you out. Since it is Friday and tomorrow's Halloween, I do want to go ahead and wish y'all a happy Halloween. If y'all need anything from me, I'm going to be kind of busy this weekend, but shoot me an email and I'll respond to you as soon as I can. Y'all have a great weekend and I'll see y'all next week.